Welcome back, guys. Today we are going to solve a problem in which we have given an array and of length n, right? And that array elements will be in the range from 0 to n, right? So we have to return the missing number from that array. So that means that the length of array is n, right? And if it has to contain all the numbers from 0 to n, then it will need n plus 1 space, right? Because we are starting from 0. So if we start from 0 till n, then it means it is n plus 1 numbers, right? But as the size of array is n, then for sure one number will be missing, right? Because actual size we need is n plus 1 to fulfill all the elements from 0 to n. So that missing number we have to return. Okay. Now, before coming to the thought process, first let's see what is the input and the output we have given. So in this example, let's say we have given this 301, right? So here the length of array is 3. So it should contain all the numbers from 0 to 3. So it has 0, it has 1, and but it doesn't have 2. It has 3. So as the 2 is the missing number in this array, so we will return 2. Similarly, in this array 0 and 1, the size of the array is 2. That means it should contain 0, 1 and 2. But it contains only 0 and 1. So 2 is the missing number and we have to return that. Okay. So now before trying to start coding, let's think of the how many possible solutions and what is the thought process behind all the approaches what we can give for this problem statement. So we are given this array 0, 1 and 3, and now we are to try to find the missing number from this array, right? As the length of array is 3, let's say this is n is the length of array is 3, right? As we can see 0, 1, 3, so length is 3, right? Now we have to find out the missing number, right? So the most obvious solution or the brute force solution can be, as we know that the numbers will be in the range from 0, 1, 2 and 3, right? As this we know from the question statement. So what we can do is we can iterate from 0 to n, that is 0 to 3. Let's say we start from 0, and this 0 we can check in our input array, right? So let's say this is 0. We will start iterating from this. Let's say this is another for loop we are doing. We will start with this 0 and try to find this 0 in this whole array, right? And we know that 0 we find it at the first place itself, right? Now we move to the second element, that is 1, and try to find 1 in the given array, right? 1 also we found here. Now we move to the next element, that is 2. Now we will try to find 2 in a given array. So we'll start from 0. 0 is not equal to 2. Then we will go to 1. 1 is also not equal to 2. Then we go on 3. 3 is also not equal to 2. That means we have not find 2 in our input array, right? In this input array. That means this is the missing element and we can simply return 2 because as there can be only one missing element, so we can exit from the loop, from both of the loop, and return 2. As now talking about this space and time complexity, and as is the brute force approach and the simplest approach one can think of is, so the time complexity will be as we are iterating through this array that is from 0 to n, that is, and also we are checking each element in this input array, right? So the time complexity for this solution will be order of n square, right? Assuming n is the length of the array. Now, as we haven't used any extra space, so space complexity of this approach will be of 1, right? But considering this time complexity, that is n square, obviously nobody and the interviewer will be happy with you guys. So our next approach will be try to think how we can make it better or optimize this approach. Now we have discussed the brute force approach. That is, we check each element from the array 0 to n and try to find the missing element, right? But how we can make it better is, as we can see that what we have given is that we have all the elements from 0, 1, 2, 3 in this array, right? And if I try to sum this up, that is 0 plus 1 plus 2 plus 3, it will give me the sum of n numbers, right? That we know. And if I try to sum up these array elements that we are given in the input, that is 0 plus 1 plus 3, right? That now this will be the sum of n elements but with one missing number, right? So if we subtract these two, that is sum of n numbers and subtracting the sum of n numbers which have one missing element, then obviously we will get the missing element, right? It is just elementary mathematics. So if we try to subtract it, then 0 will cancel out 0, 1 will cancel out 1, and 3 will cancel out 3. So answer will be 2, that is pending or remaining with us, right? Now that is, to achieve this 0 plus 1 plus 2 plus 3, we did an for loop, and it is taking us, let's say, of n time complexity as we are doing a for loop. And this also we are summing up, but this has n minus 1 elements, right? So this again, if we add this of n complexity, then this overall will be of 2n, or this 2n we can say by eliminating 2 as it is a constant. So in the end it will be like of n, and we are not using extra space, so the space complexity will be of 1 in this solution, right? So I hope you have understood this solution, because this is just elementary maths. We are summing up all the numbers from 0 to n and then subtracting and then summing up all the numbers which we have given in the input array and then doing just the subtraction. And what we will be left with is the missing number. So hope you have understood this solution, but here also the time complexity is of n and space is of 1, right? And we can have better solutions also in this, and we can reduce this time complexity further. In the previous approach, we did sum of the numbers and try to subtract the sum of the numbers of the input array, right? And we have the time complexity of n and space is of 1, right? But instead of doing the sum, we can have an alternative approach as well, right? This is a very cool concept and it will help you really in a lot of questions. So please try to understand what I will say in next few minutes. So right now what I'm talking about is XOR, right? And two important concepts in XOR operation, as we do addition subtraction, we have one XOR operation also, right? So two concepts which one should always keep in mind while having XOR, that is 1 XOR 1 will give you 0, and 0 XOR with any number, let's say n, will give you the number itself. Okay, these two operations we should remember, that XOR of a number with the own number will be 0, that is 2 XOR 2 will also be 0, and so on. Any number XOR by itself will give you 0, and any number XOR with 0 will give you the net number. Okay, so keep these concepts in mind. Okay, now listen carefully. What we can do is, earlier what we did was we did addition of all the numbers from 0, 1, 2 and 3, right? And then we subtracted this from the input number, that is 0, 1, 3, right? So this time instead of addition, let's do XOR, that is 0 XOR 1 XOR 2 XOR 3 XOR 0 XOR 1 XOR 3, right? So what I have told now is, any number XOR with 0 will give you that number, right? So 0 XOR 1 will give you 1, right? 1 XOR 2 XOR 3, right? And here also 0 XOR 1 will give you 1, and then XOR 3, right? Now again this number XOR with itself will give you 0. So this will give you 0, and this XOR will give you again 0. So what we will be left with, 0 XOR 2 XOR 0, right? And any number XOR with 0 will give you that number. So 0 XOR 2 will give you 2, and 2 XOR 0 will also give you 2. So in the end, what we will be left with, 2, and that is the missing number. So with the help of XOR operations, instead of addition, we can have our correct answer. And similarly, in this case also, time complexity will be of n, as we are looping through this and XORing each element. So it will be of n, and space complexity here will be of 1, right? So when I say time complexity is of n, so what does it mean is, like if I start looping from 0 to n, right? Because I want to have this, right? So I will start looping from 0 to n, as I'm having a for loop doing 0 to n, and XORing each element one by one. And then again, after XORing all this, I will create one more variable and do again from 0 to 3 this for loop. So this iteration will lead to this time complexity of n, and as we are not using any extra space like an array or something, so the space complexity will remain of 1, right? And why I'm saying this is a better solution, because any number, or whenever we are doing any XOR operation, it will never increase that, the resultant will never be increased, basically that number. Like if I'm doing 0 XOR 1 0 XOR 2 XOR 3, then the maximum it can reach is 3, right? That is our n. But when it comes to addition, what happens is, like we all know that sum of n natural numbers is n into n minus 1 by 2, right? Basically, if I multiply this also, n into n minus 1 by 2. So that is n square minus n by 2. This is the addition of numbers, right? So here this n square will come into this picture, right? And if n is too large, right, then this n square will be more large and you will find it difficult to store. So that is the slight difference in both the addition and the XOR approach. That the addition approach will give you n square, and if n is, let's say, 10 to power 10, right? Let's say if n is 10 to power 10, then you can imagine what does 10 to n square will give to you. But when it comes to XOR, as I told, the maximum value we can have is just the number, because any number XOR with 0 will give you that number, and same number XOR will give you 0. So we can see that XOR operation will not increase the maximum value beyond n. That's why the XOR approach is slightly better than the addition approach. So hopefully you people have understood all the thought processes and all the approaches, how we can start from the brute force and optimize it step by step and reach till here. Now, as we have discussed everything, now let's go back to our code editor and see. So now we have opened our code editor and let's try to solve this problem and do the code. So before we start, one should always careful what are the input and all the constraints. So we can see we in the input we are given an array, number array nums, and in the return statement we have to return that number. Okay, so that means first of all, what we need to do is we need to do the XOR operation of numbers from 0 to n, right? But that what we have learned. After that, we need to XOR all input array numbers, right? After that, we have to do XOR of resultant of both, right? So now let's start. We have to do the XOR from 0 to n, right? So we have to start from 0, that is let I equal to 0, and till n we have to go, and here we can include n also, and then I plus plus, right? And let's say result 1 and result 2, right? That's what we have initialized, and result 1 will be, we can initialize those values as 0 and here also 0. Then result 1 will be result 1 and the XOR of this I, right? Now we have the XOR of numbers from 0 to n. Now what we have to do is we have to do the XOR of numbers from in the given array, that is 0 till this n nums dot length, and here the result 2 will be result 2 XOR operation of nums of I, right? Now we have both the XOR result res1 res2, and we know if we do the XOR of both we will get our answer. Now let's try to run this and see if it is running fine or do we have any problem. Okay, my bad. We haven't given this number n. So here also what we can do is nums.length. Let me try to run it again and see. So the all the three base cases have been accepted. Now let's try to submit this up and see do we have any issues still or it is fine. So the our answer is submitted and hopefully you have understood how to use this XOR operation, and especially I have done this XOR code for you guys because I know that addition and all you can do on your own, but this XOR is the new approach and a cool approach, and you can try it out. And if you have any problem or any issues or any concerns in this problem, you can feel free to comment and I will be ready to help. So till now, bye bye.